In the world of software, everything is talking to everything else all the time. But how? How does that complex dance actually happen? And more importantly, what's the real secret to designing the systems that make it all possible and doing it at a senior level? Well, let's dive in. It really comes down to this one question. It's not just about hammering out code that works right now. It's about building systems that are solid, secure, and can actually stand the test of time. And right at the heart of that challenge, that's where you'll find the art and science of API design. And this quote from Heike Simonian just hits the nail on the head. We're not just looking at how to build a quick feature today. We're talking about how to architect real, lasting systems. This is the stuff that gets you to the next level. Okay, so if you want to think like a senior engineer, we have to start where all mastery begins, with a rock-solid grasp of the fundamentals. So let's get on the same page. What are we really talking about when we say API? So an API, or Application Programming Interface, is basically a contract. Think of it like a defined set of rules that lets one piece of software ask for services or data from another without having to know all the messy, complicated stuff happening under the hood. It's all about standardized communication. The classic restaurant analogy explains this perfectly. You are the client, and you've got a menu of options. You give your order, that's the request, to the waiter, who is our API. The waiter takes that request to the kitchen, that's the server. The kitchen whips up your meal, that's the response, and the waiter brings it right back to you. The beautiful part is you don't need to know how the kitchen works at all. You just need to know how to talk to the waiter. Now, there are a bunch of different API styles out there, but the most common one you're going to see on the web is REST. It's built on the very foundation of the internet, HTTP. The big idea behind REST is that it treats every piece of data, whether it's a user profile or an order, as a distinct resource that you can manage. And what's so brilliant about REST is how it just uses the standard verbs of HTTP to tell the server what to do. A GET request, that's for reading data, like fetching a user's profile. POST is for creating something brand new, like adding a comment. PUT is for updating something that's already there. And delete, well, you can probably guess that one. These four methods are the absolute backbone of most interactions you'll ever build. So once you've got the fundamentals down pat, that senior engineer mindset really starts to kick in. It's not just about how to build an API anymore. It's about choosing which architectural style is the right tool for the job. And that brings us to a huge decision, the classic REST versus its popular alternative, GraphQL. The fundamental difference here really comes down to one simple word: control. With a REST API, the server is in total control. It gives you fixed endpoints like /users or /orders, and it tells you exactly what data you're getting back. But with GraphQL, that control flips over to the client. There's usually just one endpoint, and the client sends a very specific query that details precisely the data it wants. Now, this server-defined structure in REST can cause a problem we call overfetching. Imagine your app just needs to display a user's name, but the /users endpoint sends back their name, email, address, and their entire life story. You've just wasted bandwidth downloading a ton of data you didn't even ask for, and that slows everything down. And the flip side of that coin is underfetching. Let's say you need a user's details and their last 5 orders. With REST, that's often 2 completely separate API calls, one to get the user and another one to get their orders. Making all those round trips to the server just adds latency and makes the client-side code way more complicated. And this is where GraphQL's solution is so elegant. The client just builds a single, precise query asking for the user's name and their last 5 orders, all in one shot. It gets back exactly what it needs, no more, no less. It solves both overfetching and underfetching in one go. This is an absolute game changer for complex apps, especially on mobile where every byte and every network request counts. But look, no matter which architecture you pick, a senior engineer knows that a working API is totally useless if it's not secure. And security is not an afterthought, it's a core principle from day one. To secure the gates, we first need to get 2 critical concepts straight: authentication and authorization. People mix these up all the time, but they are fundamentally different. Authentication is all about identity. It answers the simple question, who are you? Usually by checking a password or a token. Authorization comes next. It answers the question, okay, I know who you are, but what are you allowed to do? It's all about permissions. The airport analogy makes this super clear. When you show your ID at the security checkpoint, you're authenticating, proving you are who you say you are. But that ID alone doesn't get you on the plane, right? For that, you need a boarding pass. That boarding pass authorizes you to get on one specific flight. You need both to get where you're going. Same idea. So knowing the difference is step one. Step two is actually building the fortress. A senior engineer doesn't just put one lock on the door. They build layers of defense. So let's run through an essential checklist for locking down your API. Okay, this list is basically non-negotiable. First, always encrypt your traffic with SSL/TLS. That's just table stakes. It stops people from snooping on the data as it travels. Second, enforce the principle of least privilege. This just means you only give users the absolute minimum permissions they need to do their job and nothing more. That way, if an account gets compromised, the damage is contained. And finally, when you're using modern tokens like JWTs, you have to be extra careful. You need to verify the token signature, obviously, but also check that it came from the right server, the issuer, and that it was meant for your app, the audience. These checks stop attackers from just creating fake tokens to get in. Good security even extends to how you handle your errors. You need to return clear, standard HTTP status codes. For example, a 401 unauthorized tells the client, hey, you need to log in. A 403 forbidden tells them, I know who you are, but you're not allowed to do that. This gives helpful feedback without accidentally leaking sensitive internal details, which a generic 500 server error might do. So we've covered the fundamentals, the architecture, and security. But the final piece of the puzzle, the thing that really puts you in that senior mindset, is thinking about legacy. It's about designing systems not just for the next 2 weeks, but for the next few years. And this right here is the ultimate takeaway. A truly great API isn't just another feature. It's a product that other developers are going to use, and you have to treat it that way. That means writing crystal clear documentation so people actually know how to use it. It means having a solid versioning strategy so you don't break everyone's apps when you make a change. It means being predictable and reliable. That sense of ownership and long-term vision, that's the true mark of a senior engineer. So as you head back to your projects, ask yourself this question. Are you just building something that solves today's problem, a stepping stone? Or are you architecting a cornerstone, a foundational piece of your system that other people can build on for years to come? The answer to that question will define your real impact.